Okay, perfect. A little bit background to myself. I'm a channel marketing manager here at Renesas Electronics. I'm based in California. I work in the industry, in the semiconductor industry, for more than 25 years. I'm mostly on embedded system, working with customer and doing the designs on the hardware and the software side. All right, today we want to talk about sustainable and resilient cities, but what does it really mean, all right? What are resilient cities? So these are cities which are organized, robust, recover quickly from incidents, adapt to a changing environment, and they're resourceful, all right? And they have to deal, obviously, with a lot of resources they provide in their city, like electricity, water, deal with traffic, people, events, and obviously with a large amount of data. And they use these large amount of data to make prediction, to make our life easier. And over the last couple of years, these cities or these applications use relying heavily on AI in various spaces. So if you look at the artificial intelligence or AI infrastructure application, how they're built, right? Obviously, a lot of them is run in the cloud. But now there is a new trend with edge AI or at the endpoint, where you move some of the AI functionality direct to the endpoint to reduce latency, improve privacy, and also reducing cost because you don't need to upload everything. And you still do the learning in the cloud. You make use of these masses in infrastructure you have in the cloud available, but you do the inferences and treat the local data directly on the edge. AI applications for the edge and endpoint are expanding into everyday's product for real-time analytics, like that used in predictive maintenance for machines, for example. It could be in an elevator, all right, where you want to make sure that the elevator is always moving in a high-rise building and not getting stuck because you need to take them out of service. You can use voice control for smart appliances and vision for smart cameras. While Renesas has solutions for all of these areas, today I want to focus on the vision application as they tend to fit in very well with smart city topic mentioned earlier. There are three big challenges designers are facing when they're designing an embedded AI systems. One of them is heat generated by power consumption. AI development skills and scalability for product platform. Increased heat is due to explosive growth of the requirement of computation. So you compute more, you have to run your processor faster, right? Create more heat. AI skills are also difficult to secure because it's new to the edge, or AI is still relatively new. You see most of the engineers who work on AI, they are computer scientists. They're not embedded engineers designing cameras. So in a lot of application from the traditional perspective, right, people are still learning AI. And then scaling across multiple products requires designing an efficient platform where key processing devices and software can be reused. Means if you create your product portfolio, you don't want to start every time from scratch. You want to reuse your existing knowledge, your existing design on the hardware as well as on the software side. And last but not least, also on the learning, because you get to reuse these engineers building these systems. Now, well, when we look at heat and power consumption, vision AI requirements have drastically increased in the past 20 years, leading to an explosion in increase in computational demand for AI. All right, we process much more images per second, making decision on these images. That all requires massive computation. And with massive computation, obviously, comes also massive power consumption. You can see on this slide that AI model requires have gone from millions of operation, multiply accumulation operation, to over tens of billion. We now measure AI accelerator performance in TOPS tera operations per second. Frame rate and video resolution demands have also increased. Means you're not only processing a little tiny image, now you go to HD or certain thing of EMF full 4K video and to make do data analytics on these videos. This had led to an increase in computational requirements, which demands more powerful processor and therefore increase in power consumption, which generates heat. When we look at the issue of development skills, with AI being added more and more to the edge and to the endpoint, this is increasing the need for employees skilled in the AI development and deployment. Right, engineers need to change their skill set. Right, they may be Linux experts in the past, right, or software experts in the past. Now they need to learn the whole myth of neural networks and all these different AI models. The AI model creation skill set is very different from traditional embedded software skills. How do I create and train a model? What models should I use? There are endless models out there, and every day or week there are new models, right? And every model tends to be better and faster for a particular task, right? What model should I use, right? Which one I should really pick? Tiny YOLO or YOLO 3, right? There are lots of different things which could confuse the engineers. And what data set should I use, right? I think the biggest challenge in AI are not the neural networks. It's okay getting sufficient training data and labeling these training data so I can make a smart decision based on this data. What framework should I use? All right, should I use Caffe, TensorFlow? These are some terms, some tools designers use. Which one is better for me? Where do I start? Have I found that many companies are new to AI, but understand they will need it, right? I mean, they're new to the game, all right? They know that they need to move there, but how they're gonna do that, all right? Some facts, right? What we found, more than 80% of our customers are AI beginners. I mean, they're looking for guidance, for help, right, to really build the AI product. Now, the other issue to consider is obviously scalability. It makes sense to reuse as much as possible of your AI software, as well as hardware development as much as possible. Many AI-focused semiconductor devices are designed for a very specific use case. They may work very well in their intended application, but do not scale very well to multiple applications. For example, right, I have a semiconductor device, right? I can capture an image, I can recognize an image, right? But that's all based on a single image. Once I do video, right, or I have a faster frame rate, right, or I have a bigger image, right, then there is a new challenge, and often the same devices or architecture cannot be used easily. Now, Renesas has developed the RZ family of microprocessor. The RZ family is based on ARM Cortex processing cores, with the RZA being an RTOS general purpose device, and the RZG is a Linux-based general purpose device. The RZV is focused on vision AI and the solution to this issue of heat, lack of skill sets, while providing a wide range of scalability. You see here, for example, with the one where I saw the Vision AI, we have a wide set of devices which really scale from the lower end with the RZV2M on the left side, the RZ, then following the RZV2L, the RZV2MA, all the way to the RZV3X, which is the next generation. So we're constantly improving the CPU processing, but we also implemented a dedicated AI acceleration engine. We just announced our RZV2X device, which has 80 TOPS, 80 tera operation per second for really high speed image recognition, connecting up to 8 cameras. Now, the RZV family of devices are designed for the edge and endpoint in a vision application. The RZV family is powered by a variety of different cores depending on the device, ranging from an R53 to an A55, M33, R8, and also an ARM ISP core. They are designed to be scalable across the whole RZ family. The RZV uses the Renesas DRP AI acceleration engine with performance up to 80 TOPS and power efficiency of up to 10 tops per watt. So extremely low power consumption for this kind of performance, which really reduces the heat dissipation. The latest DRP-AI or DRP-AI 3 supports AI sparse model, which makes AI processing very, very efficient, all right, and increase even more the performance. The Renesas DRP-AI is a tightly coupled, dynamically reconfigurable processor. That's why it stands, DRP. And it also has some AI max integrated. The DRP-AI neural network accelerator improves efficiency for inferences and pre-post video processing. The DRP can offload heavily AI functionality from the CPU and improve performance image processing in pre and in post processing, such as color fitting, color correction, gamma and correction, noise reduction, and so forth. So in addition to providing AI functionality, right, you're offloading even more functionality from the CPU, because whenever you deal with video, right, you also have to do some pre and post processing to increase image quality of your camera, of your captured image. While in neural network models, where conventional layer are linear, operation that involves the multiplication of weights create a feature map. All right, we call it AI map. Pooling layers are used to downsample the feature map to reduce sensitivity of changes. That's also handled with the DRP. As pooling layers are used deeper in the model, different features can be detected. The function used in polling layers changes and therefore fit well with the flexibility and almost instant reloading of the DRP arithmetic unit. So the DRP unit is really, you can see it like a very flexible processor. You can reload on the fly, and you have some kind of a hardware block. You see it here on the AI Mac, right? It's really the kind of a like a lookup table in the blue box, and then you have the DRP. It's really almost like a DSP type of functionality. Now here's kind of a comparison, right? And here we show our latest product, the RZ V2X or V2H, how we call it, just released, I think, about a month ago. All right, this device provides 80 tops, and we did a comparison between the GPU, and we used a heat camera, infrared camera, to look at the heat dissipation. You can see that on the picture on the bottom. The left side is the RZ V2H, much cooler than on the right side, where you have these red spots in the middle. Then looking even further on the data, right, while the RZ V2H, we run 2 cores plus a DRP engine at 1 gigahertz, right? We get roughly 45 frames per second. Right, and on the GPU, we get half of it, and then also you look at the power consumption, 1 watt compared to 14 watt. All this made it possible because of the DRP hardware accelerator we have in there. And what runs on that, obviously, we read the data from the image sensor, we do some pre-processing, we run our convolutional networks, and we do post-processing, and we put it to the output. All these fits we do in our integrated SoCs. So quite a bit of obviously performance boost, but also reduce the heat dissipation, which are some of the main challenges of designers. Now, for the development skills problem, Renesas has developed solution to reduce the need for a specific AI skill set, ranging from our reality AI for real-time analytics and audio on our MCUs. So we have a separate tool set and a separate application using AI on our MCUs. I'm not talking about that today. Today we're talking about our MCUs. Where we also provide pre-trained models for our RZV series for vision AI application. But if you Google reality AI, you find a lots of cool stuff running predictive maintenance and voice detection on our little tiny MCU. And obviously, our tiny MCUs are very power optimized, using only a couple of microamp. Now, many AI semiconductor manufacturers provide some type of development environment or SDK and model examples. Renesas has taken this step further and provided a complete solution with pre-trained models for many different applications. Those highlighted in the red are application we find in smart cities, like those of described by companies called Arctus. So, and I talk about these models a bit later. So on the left side, all right, you see what companies typically provide, the SDK, all right, and some models, and then you're up on your own, right? Take a model, do the training data. We already have done the training data. We have pre-canned solution, which can be used in your application as a starting point, and then you can take these and modify it, add more of your own training data and so forth. Now, Renesas also provides a large third-party ecosystem, right? And here are some of the partners. They're really ranging from system on a module, hardware vendor, or single board computer. In the previous session, it's a gentleman from Blues talked about using Raspberry Pi and single board computer. We also have several of these available to our third-party companies, and obviously lots of different software vendors here as well, which provide additional skill sets to the designer, so they don't need to acquire them. Now, Renesas RZV product portfolio are scalable, right, ranging from 0.4 tops all the way at the bottom, the V12, and we talk a little bit later, because it's a perfect entry device to get started, all the way up to 80 tops. So you see the performance, but you also see when the device will be available. You also on the right side, you see the major features of how many cores we have in there. On the top device, the RZV2X house listed here, we have 4 ARM55 cores. We have an M33 core, and we have 2 R8 cores. We have a graphic engine, a video engine, all right, also DRP engine, and we have OpenCV accelerator, as well as MIPI as well, and an ISP. Now, I want to spend some time on the RZV2L, which is really our entry-level model and sufficient for lots of different application in the AI space, for smart city or for resilient cities, where you can do people counting, people detection, right, car detection. You could build a camera to detect free spots on the parking spot, for example. The RZV2L is a 1.2 gigahertz ARM 55 core, available in single or dual core. It has a DRP AI engine then for neural network acceleration. It also has a 200 megahertz ARMS 33 core. This one is like a microcontroller, and you can do control for sensors, for example, if you want to build a camera which measures temperature and humidity. You probably would do the temperature and humidity data acquisition on the M33 core. It has a 3D graphics engine with a Mali GPU, so you could hook up, for example, a display. It also has some video encodec, H.664 and 265. That's the camera and display interface, and 2 gigabit Ethernet interfaces, and it comes in 2 different package sizes. Now, the question is, how do I get started? All right, so now I see, okay, right, you have Renesas, you have this RZV family, but I don't know where I am. I just want to make some experience. So Renesas worked together with Avnet to design the Avnet single board computer, called the RZboard. Right, this is a Raspberry type-like form factor, with a Raspberry Pi 40-pin header, and it provides gigabit Ethernet, Bluetooth, and Wi-Fi. It has SD card interface. It has 2 gigabyte of DDR4 memory, 3 USB port, a CAN connector, HDMI, MIPI DSI interface, as well as a CSI interface for the camera. You have an audio jack, and it comes in a very compact form factor. Can be used any kind as a single board computer. So in the previous session, for example, where you need to have a compute engine, you can use this board, but it's really tailored for embedded vision and AI. Looking at the block diagram, right, the heart of this board is the RZV12, but Renesas also provides the whole complete power device as a PMIC, as well as clocking. We also have our own codec, which is on that board. We have our CAN controller, USB hub, and power supply. And we also have a MIPI switch. And so lots of different devices. What we do here at Renesas, right, all combined on a single board computer. And here you see a little bit more the specifics, right? Obviously, everybody can detect the gigabit Ethernet, the 2 USB. There was also a USB OTG port, some CAN ports, a UART interface. You have your stereo audio codec, your MIPI CSI. So you can hook up a Raspberry Pi camera, and I'll show you later which one we have tested. Then a micro HDMI port, you can hook it up to your monitor and use as a standard Linux computer, AI computer. We have USB Type-C power supply, some buttons. You can hook up a display. We have 2 LEDs on the board. Obviously, the antenna for the Wi-Fi. On the bottom of this board is a micro SD card and the 40-pin Pi head expansion header. That really makes this board very universal, using for a variety of different applications. Not only for vision AI, but you can hook up sensors, you can put up some control, and so forth. There are additional resources available, right? For example, you can use any kind of expansion board or Pi head. There is a huge ecosystem of Pi heads, and Avnet has some DSI modules available, right? Some relay boards, some LEDs. All these can be used to put your prototyping system together quickly, right? There are also Pi head boards available for some LTE modems, right? So if you want to connect your RZboard to the cloud but don't have Wi-Fi and Ethernet available, you can use some of these boards as well. Now, obviously, there are over 1,200 clickboards available, and with the expansion board, you can hook up these things as well. Here are some peripherals which are available from Avnet, the display as well as power supply. And there is also a Raspberry Type kind of camera available from Aducam. Can be ordered directly from Aducam's or Avnet's website, and you see they're relatively inexpensive. In addition, obviously, Renesas also has an evaluation kit. This board is slightly bigger, but also provides additional feature like a 2nd gigabit Ethernet or a 2nd CAN board. All right, it also provides 2 large eMMC memories and also QSI and NOR flash. This board is available directly through Renesas, while the board on the left side, the RZboard, is directly available for $149 from Avnet. Now, obviously, that's all on the hardware side, right? What software does Renesas provide? So first of all, right, because it's a single board computer operating Linux, you gotta have a Linux package, and we have our verified Linux package, which customer can use free of charge. It has certain elements. It has a BSP. It has a Linux stack. It has some secured middleware, right? Some software for the video codec, GStreamer. It also has a GUI framework. We provide Qt and HTML. So very comprehensive software suite as well. And obviously, whenever you deal with AI, right, you need to take your data set, what you use for training, and you may use TensorFlow or PyTorch or Caffe. You use these tools to create an ONNX model. This one is a standard model, output models of all these tools. You take these model and feed it to our DRP AI translator, which converts basically your training data and neural networks or trained model into an understandable data set for our DRP AI engine. and then the Linux driver just downloads it to our device, right? And then you write a little application, you acquire some image from the camera sensor, you feed it to our DRP-AI engine, right? And then you get an output of the device. Here it's a slightly different view, right? So we use open source trained model, right? Whatever you feel comfortable, as long as you get an Onyx model, you're good. All right, and then there are the development tools from Renesas. So beside our Linux BSP, you get the DRP AI translator, and also the DRP, the software driver, which are implemented in our Linux kernel and downloaded to the board. Now, how do I find more? Right, we have a variety set of data sources available. All right, obviously the first thing is if you go to renesas.com, right, and then you click on the products for 64-bit MPUs. You see a little section RZV series. If you click on that, you find lots of different information, data sheets, software guide, BSPs, and so forth. We also maintain a wiki page. If you go to renesas.com wiki and /RZV, you'll find specifically information about our RZV, their instruction, guidance, and so forth. Avnet maintains their RZ page for the RZboard, and they also have a blog there. They also have a links to Hackster.io, where you already can find a bunch of different interesting projects. Right, there was a project, for example, for a trail camera, right, where we use the RZV together with another microcontroller and some sensor to build a battery-operated camera. Basically, it puts the device into sleep mode as there is nothing detected, and as soon as an object is detected in front of the camera, the system wakes up. Has the advantage that you really can make use of a low storage battery, because some of these trail cameras, they're mounted in the woods and nobody touches them for weeks or months. There is also a GitHub entry available. That's where we list a lot of different applications. All right, and if you want to read more about the DRP-AI engine, there are some white papers available in the links below. Oops. So some key takeaway, right? Renesas has the RZV MPU product family, which provides very flexible performance and power efficiency for real-time vision AI application. We also provide scalable solution for the to solve the embedded AI challenges. So everything from a low end going from 0.4 tops all the way up to 80 tops. So no matter which application you're designing, right, you still stay with the RZV framework. That means all the tools, right, all the behavior, all the things work. It's exactly the same. And we have easy to use tools and also a large third-party solution networks, which really get you to the goal quickly. Resiliency AI solution contribute to innovation of creating really edge and endpoint products. So we have multiple design wins in camera, machine vision, where we do, for example, object detection. We have one application where a customer uses us for a camera to do parking spot monitor. So they have a bunch of cameras spread over a parking lot, right? And they can see where the empty parking spot, and then they have a guidance system where they guide actually the cars to these empty spots. And the single board computer is widely available from Avnet. All right, that's really a good starting point to get started. Very easy to use, very easy to get, and inexpensive. Okay, with that, I'd like to see if there are any questions.
All right, so we do have a few questions that came in. Thanks, Dirk, for that presentation. One of the first questions we got was, does SBC run both Linux and RTOS?
The SBC runs, correct. So the RTOS would run on the M33 core, all right, little tiny microcontroller core, which you would hook up to a sensor, for example, or can use it for anything else. And Linux runs on the ARM55 core or on the ARM53 core, depending what kind of device you have. But usually we put always some kind of a microcontroller device to run RTOS in there.
Great, thanks. You showed an example of vehicle and pedestrian counting, but I'm wondering if the object detection could manage turning movement to indicate count vehicle turning movement at, for example, an intersection.
Yeah, you could do that also. You probably what you would do, but you would need to read 2 consecutive images and see, okay, how does this image has changed? I mean, does the same person move to the left side and then to the right side? You can also, yeah, detect actually the flow. I think there are a bunch of applications where people were looking at managing people moving in a shopping mall, for example, which direction are they going, or big events, right? And then developing a guidance solution from that. But it can be done, yes.
Excellent. I think we had a couple other questions. I just lost my question thing here. Here we go. Could you run this hardware with solar panel or other renewable energy source? Like any recommendation for powering smart city solutions in the field?
So the way how you do that, and that may be how we did this, for example, for the trail camera, right? Because you may not need to have the camera all the time. You could have a solar panel, charge a battery, all right? And obviously, if the system turns on, you need to have more power than the solar panel can provide, unless you have a very big panel, all right? But then you take power out of the battery, the system goes back to sleep, and you charge your battery. So you use the battery as a buffer, and that will be we have done with one of our trail camera applications. A lot of these trail cameras use batteries.
All right. Any favorite microelectronica clipboards for smart city applications?
Favorite, depending what you want to build, right? I mean, for a smart city, I mean, I can speak from the Renesas side. So we have a bunch of different sensors. We have temperature, humidity, right? Which obviously is always good to have. You want to see, hey, how warm or humid is in the city. But more important is we also have an air quality sensor. And I think everybody wants to know, okay, is it healthy? Is it good to go to the city? Or how is the air quality on a certain intersection or even in a room, right? So our air quality sensor are probably a good thing to start off. It gives you an estimate about and there's a variety of different applications. It could be an HVAC system, right, where you measure the air quality of the air you're pumping in or out of the building. It could be intersection. I had one customer, for example, they built a wireless access point and they put an air quality sensor in the wireless access point. Why? Because they have these wireless access point deployed in a big building, right, in the convention center, and they have access to the data. So they want to see, okay, how do I need to control? Is it really, does it feel comfortable to be in that room? Right. So these are these air quality temperature sensors, right, are probably one of the of my, at least my favorite sensors.
Awesome. Yeah, there's so many of them. All right. So then I think the last question we have before we end today is about software licenses. Is there a fee for those? I know you'd mentioned the software.
No. Our BSP or SDK, right, comes free of charge. You would need to sign some license agreement, but it's more because we use, for example, the Mali core comes from ARM, right? It's free of charge, but we want to make sure that yeah, not everything works in a good way, right? And you're aware of the standard license requirements.
Awesome. Well, thanks. I think that's the last of our questions. So thanks, Dirk, for joining.
All right. Thank you. Well, it's a pleasure talking to you.